company is really focused on the development and commercialization of technologies that enable better, cheaper, safer batteries. And what that really means in the context of our activities is commercializing technologies for the production of lithium metal and metallic lithium anodes. Why that's important is because the next generation of batteries, and when I talk about next generation batteries, I'm really talking about an umbrella of solid state batteries, hybrid lithium metal liquid electrolyte batteries, and lithium sulfur batteries. These are all batteries that rely on high energy anode materials. And what they're really aiming to do is to create a step change in the performance of lithium ion batteries or beyond lithium ion batteries. So what that really means is higher energy density. It means safer batteries. It means longer range for electric vehicles and ultimately lower cost electric vehicles. So it's a big deal. And as I said, that's almost entirely enabled by changes in the battery chemistry that allow you to use high energy anode materials. Sorry about that. So, I'm sure we've all seen this graph or graphs like it. This is one of the biggest things that's happening industrially is electrification, and particularly of passenger and commercial EVs, really driving the demand for batteries going into the latter half of the decade. It's a many-fold increase in the size of what is already a significant industry. What this graph doesn't show is that as this is happening, we're actually going to start seeing a technology transition to next generation batteries. And that has huge implications on the upstream supply chain. And Li-Metal is really aiming to be a midstream player. We're not a battery company, we're a midstream player supplying these materials, these critical materials for next generation batteries. And we're watching the development very closely. If even the top three, let's say, next generation battery companies realize their plans for production, the next generation battery industry in 2028 would look very much like the lithium ion battery industry did in 2020 in terms of size, and growing rapidly thereafter, and starting to make up a bigger and bigger chunk of the overall lithium ion battery production. So of course we're aligning our goals. Again, it's a big impact on the supply chain. We're aiming to be a big part of that supply chain. And so we're really looking to be in commercial scale production in 2025, which is very much in line with what the major automotive OEMs and battery developers are projecting. So you can see here sort of a summary of the major automakers. They've all committed to having next generation batteries in their vehicles at some point, mid to late decade. And there's a significant amount of, let's say, pre-production product qualification that happens. So we're keeping that in mind, and that's why we're aiming to be in commercial production relatively on a short time frame. What is it exactly that we're doing? We're addressing two critical problems in the next generation battery industry, or we're removing two key obstacles. And I'll talk about them in turn and give a bit more detail about what it is that we're doing. But essentially, the way lithium metal, which is sort of the preeminent, arguably the holy grail of anode materials, the way that gets into next generation batteries is as a metallic lithium foil. The process for producing a metallic lithium foil is in many ways similar to the process that's used for producing the aluminum foil that you may find in your kitchen drawer. The problem is that lithium is a much more difficult material to work with. So in order to produce a foil, you end up making it thicker than you would absolutely want. And you tend to make it narrower than you would absolutely want, which both of those things have negative impacts. One on the cost in terms of the scalability of the production process, the amount of material that's used, and ultimately downstream how it's incorporated to the battery. Ideally, you want things to be all the same width so you can laminate them in parallel, which you can't do if one component's a lot narrower than the others. In terms of performance, if you're using more material than you want, you're kind of clawing back some of those performance gains. And of course, more lithium means more active material, excess lithium in the battery, which has a negative impact on safety. Moving to metal production, obviously, if you're using metallic lithium anodes, you need lithium metal to produce them. Currently, the lithium metal industry, we often see articles or commentary referring to lithium as the silvery white metal in connection with lithium-ion batteries. Actually, very little of the lithium that goes into batteries today is metallic lithium. It's usually going in as a salt. So the lithium metal industry today is more of a cottage industry, very highly concentrated in China. That means that as the European and North American auto industries grow and the batteries and industries that support them grow, you actually need to develop a lot of production locally in those continents. There's a lot of issues and a lot of concern about supply chain security. The process that's currently used to produce lithium metal is quite an old process, and it uses a very specialized precursor, which is high purity lithium chloride. Again, kind of a low volume chemical, so limits the extent to which you can scale that production. It also has this nasty side effect in that when you split the lithium chloride, you're producing the metallic lithium, but you're also, for every ton of metallic lithium, producing 5 tons of toxic corrosive chlorine gas, which has to be captured and treated, and has all kinds of health and safety implications and environmental implications, which ultimately serve to increase the cost and make it more difficult to scale that production. So we have these two, let's say, complementary problems that we're addressing through our technologies. So the way we're addressing the anode issue is by completely changing the process for the production of anodes. So rather than taking a hunk of lithium metal and squishing it down into a foil precursor and rolling it down, what we're doing is we're starting with the current collector, which is a component that already goes into the battery, and we're depositing lithium metal onto its surface. That allows us to deposit an arbitrary thickness of material. Because we're doing it on the substrate, we're no longer relying on the mechanical properties of lithium metal, so we can make it arbitrarily wide to match the width of whatever battery production process, or whatever is optimal for the battery production process. Because we're doing all our deposition in a vacuum environment, we really control the level of contamination or anything else that can get onto the lithium, which improves its performance. And also, we're actually able to do things to that material that you can't do with lithium foil. So there's a lot of upgradability and a lot of customizability that's inherent in the process. We're relying on a physical principle that's been used in the packaging industry. So it's a technology that's it's more adapted than it is completely new, and so we can be very confident in the scalability, because that's it's already understood from other industries that have used sort of similar technologies. Moving to the metal side, the process we're using is in a way fundamentally different from what's currently used to produce lithium metal. We're using it's still an electrowinning process, so in some ways, in principle, similar, but the precursor is completely different, and that forces an entirely different equipment requirements and so forth. So we've developed our own custom equipment for the production of lithium metal. What using lithium carbonate allows us to do is it basically permits us to bolt on the entire lithium-ion battery supply chain, or the existing lithium-ion battery upstream supply chain that normally produces lithium salts for lithium-ion batteries, and we can actually use that to produce the metal needed for next generation batteries. By eliminating or by switching that precursor material to lithium carbonate, that eliminates the production of chlorine gas from the process, and so we can eliminate a whole bunch of equipment, a whole bunch of OpEx that's associated with capturing and cleaning those materials. And of course, again, that has an impact on cost, so we expect this process to be more economical. In terms of our strategy, we have a very robust strategy for getting to commercial production. We're currently now, but I guess the overall concept is basically to really entrench the technology, to entrench our anode materials in the emerging players' technologies. So we're working with a lot of next generation battery companies, and so most of the work that we've done over the last year and a half has been to build out pilot production capacity for metallic lithium anode materials that is now operational. And so we're able to supply those materials. We're able to ship product today. As we look forward, to 2023, the next step is to build a commercial scale demonstration plant. That's now sort of a one-off of a multi-machine line that would produce sort of at the machine itself produces close to gigawatt scale, and to build a gigafactory, you would simply use more of those machines. So once we're at that step, then scaling again is basically relatively straightforward. So we're looking to do that next year, and then getting to gigawatt scale in the 2025 timeframe. Supporting this, we're also aiming to localize lithium metal production, again through our cleaner and more cost-effective process. Again, so that we can be a reliable local supplier of these materials to the primarily to the automotive industry. We have a very experienced board of directors supporting the management and technical teams, people with experience all through the lithium supply chain. My co-founder Tim Johnson, also very active in the lithium industry for the last 15 plus years. He's also a co-founder of lithium-ion batteries of the recycling company, Li-Cycle. All of these individuals have a lot of experience in both in the lithium industry and also in many cases in developing venture companies. Just talking to some of the things we've been able to achieve in 2021 and 2022. So we are now listed on the CSE under ticker symbol LIM. We've completed the build out of that Rochester pilot scale anode production facility that allows us to supply material to battery developers in the United States. Very exciting. Actually, this was announced only a couple of days ago. We've signed a joint development and commercialization agreement with Blue Solutions. And I'll talk about that in a bit more detail on the next slide. But the big goals for the rest of the year really are to complete the expansion of our Toronto facility, where we'll be piloting the lithium metal production process, and to run those piloting activities, really demonstrate that can work properly and achieve the performance metrics at an industrially relevant scale. So the Blue Solutions agreement is very exciting because Blue Solutions is really the only commercial producer of all solid-state lithium metal batteries. They've been operating for a number of years, producing materials or producing battery packs for stationary storage and more significantly for fleet and bus type applications. They have a ton of experience with lithium metal. They understand solid-state batteries, next generation batteries. And so it's sort of a perfect marriage of our technology for producing advanced anode materials and their expertise with lithium metal. So what we're really going to be working on is developing an ultra-thin anode material that will then be able to support both the current generation of LNP or solid-state batteries and the follow-on technologies that are expected to be rolled out later in the decade. So it's really, really exciting. There was a lot of work to get the deal done, and we're excited to start working under this agreement. I'll just speak to the facilities a little bit, because we do have two facilities. So Rochester is a smaller facility, but it's where we have our anode production plant. This is a plant that's capable of producing thousands of meters of anode material. So this is it's sort of a dual use facility. On the one hand, we're producing sample material, and on the other hand, we're running sort of industrialization trials on second generation products and so forth. So it's sort of a mixed use development and sampling facility. In the Toronto facility, we actually have two areas other than it being our headquarters. We have just at the end of the previous year, or the end of last year, completed commissioning of our anode materials, advanced anode materials development lab. This is a really flexible facility. It allows us to work on materials that, beyond our initial product offering, will allow us to deliver better electrochemical performance, potentially better cost performance. And so this is sort of going to work in tandem with the pilot facility to bring those to fruition. I've already noted this, but this is the whole facility is a 14,000 square foot facility. The main process area will really be where we're going to build out our lithium metal production pilot line. This is actually an old photo now. We've got quite a bit more equipment installed there, and we're expecting that to be online, sort of initial operational capability towards the end of the first quarter of this year. So basically very shortly. With the follow-on sort of piloting campaigns running throughout the year. That's what I have for today. So thank you very much for your attention. I'm happy to take any questions.
Great. Thank you very much for the informative presentation. We'll now move to the Q&A session here. We do have a question or two. What agreements do you have, or I guess sometimes it's proprietary, but what kind of agreements do you have in place with both suppliers and customers?
So we've just announced that agreement with Blue Solutions. That's the only one that's been disclosed publicly. And so, yeah, I mean, that's the only one I can really talk about at this stage.
Okay, great. And obviously, with the work that you've done to date, that's an area of potential growth as you build your customer base. And
absolutely.
And I guess looking at the supply side, is there any risk to supply of lithium for your products, given kind of the competitive marketplace out there?
Yeah, look, I think it's certainly an area that we're working on. I think the key differentiator for us relative to another company trying to do something like this is that because we can use lithium carbonate, there's actually a much broader marketplace of materials that can, over a much broader list of potential suppliers for what we're doing, whether that's virgin material or recycled material. We can use that in our process, whereas a conventional lithium metal producer would need to source or produce themselves high purity lithium chloride. So I think we're at a big advantage there. But of course, in a tight market, everybody needs to find their input materials. But again, just sort of looking at the technology stack, we've purposely sort of set up the company so that we can produce our own lithium metal, because that's, again, if you think lithium carbonate or lithium hydroxide is in tight supply, the metal situation is much more so.
Great. And one general question more about the lithium space, but what new technologies are out there for batteries, and what do you see as growing technologies, or growing types of batteries that you'd be able to supply to?
Yeah, I mean, it's a great question. There's a number of different, and I mean, this could be an hour discussion, so I'll keep it short. But basically, there's sort of two or three main thrusts in terms of technology. So you have solid state batteries, where you're replacing the liquid electrolyte with either a polymer oxide or sulfide separator material, or you're replacing all of the electrolyte, whether that's in the separator or in the electrodes themselves, with a solid material. That has the great advantage of eliminating a lot of the fire risk that current lithium-ion batteries struggle with. And in many cases, it enables the use of new materials, like, for example, high-energy lithium metal anodes. On the other side, you've got liquid electrolyte batteries that are using sort of non-conventional electrolytes that are more compatible with lithium metal. Oftentimes, they also have much more favorable sort of safety characteristics. And so that's, if you think about this first group being sort of like Blue Solutions, Factorial, Solid Power, those types of companies. On the liquid electrolyte side, you have groups like SES and Cuberg, et cetera. So there's a number of these different technological approaches. There's also the sort of slightly more exotic lithium sulfur batteries, where you're actually eliminating the cathode material, the traditional sort of ternary cathode material and replacing that with a sulfur-based cathode, which is of course much cheaper, much more abundantly available. So I think all of those in the immediate term will compete both for commercialization and then once commercialized in terms of different applications. They'll have slightly different characteristics, and so I think they'll find niches where they're sort of more or less applicable or are better or less well suited. And so I think it's super exciting. You know, there's a lot of companies racing to develop these technologies, and we want to just support them with our products.